Hello, so today we are going to do this problem, lowest common ancestor of a binary search tree, which is part of Leetcode daily challenge. So we have a BST and we want to find the lowest common ancestor of two nodes that we get in the input. And the LCA is just the lowest possible parent of both. And BST is a binary tree where the left side is smaller than the root and the right side is bigger. So if we take a look at this example, we have 2 and 8. So the lowest parent they have together is 6. If we take a look at the second example, 2 and 4, 4 here, 2 here, the lowest parent is 2, right? And so it can be one of the node itself. So that's one thing we can tell from here. So how can we solve it? Should be pretty easy to think of the first solution, which is well, we know that if the p-value is smaller than the root value, or the node that we are looking at, and q-value is smaller, so both are smaller, that means we need to search on the left side, right? Because both are smaller, so the parent is either that root or something on the left. The parent is definitely on the left side, right? Because it's small. Both are smaller, and by the same idea, if both are bigger, that means since this is a BST, this is the property of a BST, if both are bigger, we need to look at the right? Otherwise, that means we found our LCA. So if it's in between, if the node value is in between both, and they are not both smaller and not both bigger, that means it's actually in the middle, and it's the first one we found in the middle. That means that's what we are looking for. So else we can just return root, right? So that's the main idea. Go left or right using the BST property, and then if you find the first one where the root is in between both nodes, that means that's the LCA we are looking for. So that's the idea that we are going to implement here. So while root, we can just check if both are smaller than the value. Then we need to go left, which means we need to assign root.left. Otherwise, if both are bigger, so let's just change the sign here, and then we need to go right. So this is else. Now, otherwise, that means we found the first one where the root is right in between both. That means it's the LCA we are looking for, so we need to return it. Otherwise, when we exit and we didn't find it, we will have none. So we can either return none here or return the root. We didn't find any. And that's pretty much it. You can also do this recursively. You just need to handle the base case of root equal to none. And then you can do the exact same condition, except here, instead of assigning, you can recursively call it on root.left or recursively call it on root.right. Otherwise, you can also return in your recursive function. Yeah, so let's run this, make sure it passes test cases. Okay, so it does pass test cases. Now, in terms of time complexity, this is, we are doing only one side, right? Either go left or go right. So that means it's the height of the tree. So it's O of height of the tree. In terms of space, we are not doing any extra space, so it's O of 1. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.